So what we have here is example 1 from chapter 1, the parent guide. Let me write that on here. Parent guide. And this particular one is giving you a function which they have in their machine right here, which is f of x equals 10 minus x squared. And it wants us to work on a through d to see what each of those things equals. So what I'm going to do first is I'm going to go ahead and do A. And in fact, I'm going to change it to white because it'll show up better. They want us to see what happens when 2 is dropped in. So 2 is our input. So we would rewrite it as f of 2 equals 10 minus 2. And I always put parentheses around it just to make sure. Well, this one is just 10 minus 4. So it equals 6. So f of 2 equals 6. So we have the first one done. Then we're going to go ahead and do B. And this is where the parentheses kind of become important. So f of negative 2. And we're going to put 10 minus, and we're going to put negative 2 in parentheses squared. Really important here, because if you put it in the calculator without the parentheses, it will give you back a negative 4 because of order of operations. So again, though, negative 2 squared is 4. So 10 minus 4 equals 6. So we have f of negative 2 equals 6. So the next one we're going to drop in is C, and that is the square root of 10. So f of the square root of 10 equals 10 minus the square root of 10 squared. Well, the square root of 10 times the square root of 10 is the square root of 100, and that just equals 10. So we have 10 minus 10, which equals 0. So f of the square root of 10 equals 0. Now for part D, it's a little different because they give us a decimal. So I'm going to go f of negative 3.45, and it equals 10 minus negative 3.45 squared. So when I actually put negative 3.45 and square it, I have to remember to put again in the parentheses. Otherwise, we would end up with a negative outside there. So when I do this, I end up with 10 minus, and then in the parentheses, you're going to have 11.9025. And that is negative 1.9025. So f of negative 3.45 is negative 1.9025. Now, I'm going to go ahead and put together just a really quick table here. So it's not going to be real pretty, but I'm going to go X and I'm going to go Y. Then I'm going to put my input for f of 2, and my output was 6. My input for f of negative 2 was also 6. My input for square root of 10 ended up being 0. And probably the weirdest of all of them, which, not all math numbers are not weird. I mean, some of them are really strange. So, okay. So then we would have an input of negative 3.45, which leaves us with a negative 1.9025. Okay. So that's our table of inputs and outputs for this particular graph. So now what I want to do is be able to show you a picture of that graph so you can see it. And then we'll also talk about whether or not it is a function. So hold on. So what you'll see here is that I've actually gotten rid of all of our work, and I brought over our table of values, which are right here. And now I'm going to plot those points. And so I go to the X value first. So we're looking at 2, 6. So 2 up to 6, and I plot the point. Then I go to negative 2, because we always go horizontally first before we move vertically. Negative 2 up to positive 6. So there's that one. Well, then we have the square root of 10. Well, if you plug square root of 10 into your calculator, you get approximately, and it's got to be rounded, about 3.2. So if I look at 3.2 on the graph, we've got 2 And then there's 3. Well, it looks like it's trying to do 3.2. Well, there's my 3.20. And the same thing would happen on the other side, even though we don't have this on the table. That's a negative 3.2, roughly. So if you had the negative square root of 10, and you put that into the square root, it would also be negative 3.2, roughly. Well, then we have our last point to put in. That's a negative 3.45. So we've got a negative 3 right here, 0.45. So roughly, let's see here, we have 1, 2, 3, negative 3.45 takes us down to a negative, almost a negative 2. So that's right there. So that plots those points that we've been given from these 4 equations. The other thing I wanted to point out to you, because I've been doing that with the other videos, is another way also to check whether or not this is a function is using that vertical line test. So if I draw just a vertical line, and I'm going to go here and get my line, okay, and I just draw a vertical line through this graph anywhere. So I've got a vertical line there, and then I'm going to do it again, and I draw another vertical line, and then one more, just to kind of get you used to what I'm talking about. If you notice with these blue lines, they are only hitting the graph at one point, and that on the vertical, they're only hitting at one point. So that means that this does pass a vertical line test, so it is a function, which for some people, they know it's a quadratic. It's also a parabola, but you know it's a quadratic because the x term is squared. So that helps you with example 1, and now we'll move on to example 2. Okay, so this is example 2 in chapter 1's parent resource guide, and we're going to take each one separately, each particular section. So it says A, B, C, D, E, F, but I'm going to look at A, C, and E right now. So the first thing I'm doing is I'm going to plug in the f of 4. That means I'm going to take the f function, and I'm going to plug 4 in as its value. That means I have to substitute 4 in for every x. And then I just do the math for that. So the f of 4, and this is 2, because the square root of 4 is 2, over 3 minus 4. So it equals 2 over a negative 1, which is negative 2. So the f of 4 equals negative 2. Now, that's going to help with what we're going to show here. I'm going to show a little video to talk about that, and then I will talk about the domain and range after we're done with that. So let me go ahead and show you that video. Hey there, so we actually just solved for f of 4 and we got negative 2. So we're going to check things with I'm going to go ahead and clear my keystroke here because you really don't need to see all of that. We're going to go ahead and check our answer, but we're going to actually work through the graphing calculator, the TI-84. This is my emulator software, but many of you will be working from this kind of calculator, especially in class. So the first thing I want to do is put that equation in, and we had it as y equals, it's the square root of x, so I'm going to hit second square root of x, and then I'm going to hit divide. Well, actually, first I'm going to get myself out from under the radical, so I don't have anything under the radical except x. So I just hit this right cursor. Then I'm going to hit divide. And because I'm worried about order of operations, I don't want to divide by 3 first, so I want to make sure that my denominator is in parentheses. And so I'm going to go ahead and put 3 minus x. And that's my equation. Now let's go ahead and we'll just hit the graph button to see what the graph button looks like. All right, so here's what our graph looks like. Now, I want to check some values. I do want to check the one that we did that was for f of 4, but I've got to check some other ones too, because we're going to talk about what the domain looks like and what the range looks like for these graphs. So I'm going to come to the second table. I'm going to hit second table to make sure or second table set, so second window, and I want to make sure I can enter the values I want to enter. So I'm going to come down here. I'm going to go down to auto on the independent variable, and I'm going to switch it over to ask, and I'm going to hit enter. Now I can go to the tables and put in whatever value I want for this particular equation. So I'm going to go second table. Okay. You see there's nothing there, but now I get to put in the values that I wanted to check. So the first thing we're going to do is check the value that we actually did on our f of 4 equation. So let's plug that in. If we did it correctly, we should have a -2 as our answer. So let's check and see what happens. Sure enough, we do. Now, what I want to do is go back to the graph just momentarily because I want to talk about a specific value on this equation. If you notice here, this graph is coming from the left and it's going up, but it's going towards 3, but it's never going to hit 3. This is what we call an asymptote. It gets infinitesimally closer and closer to the x equals 3 value, but it will never hit the 3 value, and there's a reason for that. And as you see from positive infinity over here, you're going to see also that it doesn't hit that. So what I need to do is let's go back and look at the equation for a minute and see what do we think is wrong with the value of 3. So if I go back to this equation and I look at 3, well, 3 minus x is in my denominator. If I plug a 3 value in here, I'm going to have a 0. And we cannot have a 0 in our denominator because dividing by 0 is undefined. And so that is why it doesn't work. Well, let's go back to our table for a second. I want to come in here and I want to plug in 3 and see if that's really true. So I'm going to plug in 3 and we're going to see what answer we get. We get an error. And that is because that value does not exist in this particular equation because it would be undefined. But let's check the values around 3. So let's look at 2.99. And let's hit enter. Yes, we have a value, 172.92. How about we check above 3? So we're going to go 3.01. And yes, we have a value there. So this, if we were talking about discontinuity, that means at this x equals 3 line, we would have discontinuity, meaning infinite discontinuity, because if I put in 3.001, look at that, it goes to negative 1,732. If I put in 2.999, it goes to 1,731.8. You don't need to know that as much right now. The most important thing that you get from this little video is that if I plug in 3, it's undefined. And that's going to help us answer the other questions that are asked on this particular guide. So that's it for this graph. We'll have another video in a moment for the second graph as well. Okay, so now I want to talk a little bit about domain and range. And so C is domain. And it's asking us, what's the domain? Well, domain is all x values. So on this one, it's a little trickier than range. On domain, we already know we can't have x cannot equal 3. But we also know, if you're looking at this carefully, x has to be greater than 0 because we can't have the square root of a -1, for example. You can't have the square root of -1 over 3 minus a -1 because this is considered imaginary. So it's kind of important to realize that that is why this particular graph stops here, because this area cannot be part of the domain. So I'm going to go ahead and erase this work here. So oops, sorry, I thought I hit the eraser. I'm going to hit this right here, and then we're going to talk about what the domain looks like. So if I was stating the domain, I would state it with a D, and I would say x is greater than or equal to 0, but x cannot equal 3. Okay, and there's different notations that you can have at some point, but right now that's just a good way to say it. The domain is greater than or equal to 0, but cannot equal 3, because we have our asymptote here, which we've talked about earlier. Okay, so that's the domain. Now the range, let's do that in a different color. That is E. For the range, it's pretty easy. It's all real numbers. So you would say, you could say all reals. You can also say, there's another notation that goes negative infinity to positive infinity, but it's just all real numbers. So there's not a single value that y has that would not be part of this graph. So that's the easiest part on that one. So let's move on to the second part of our equation, which is B, D, and F. All right. So on B, D, and F, let's just start with solving like we did on the last one. I'm going to go ahead and plug in G of 4. Well, that equals 4 plus 5 squared. So that's going to be 9 squared, which equals 81. So the G of 4 equals 81. Okay? Now, I want to show you something else too about this. So we have x plus 5 squared. So it's x plus 5 times x plus 5. Now, you may have learned, I'm not sure if you've learned this yet, but you can do a box method where you take the x and the 5 and then the x and the 5 of the other equation, and then you just multiply them by the table. So we would do x times x, so that would be x squared. Then we would do x times 5, which would be 5x. Then we would do this x times this 5, which would be 5x. Then we would do 5 times 5, which is 25. And what you get from that is you combine like terms. So I only have one x squared. So I'm going to circle that. So I have x squared. Then I have two 5x's. So that's going to be plus 10x. And then I have 25. So it's plus 25. So this is x plus 5 squared expanded. Okay. Another way to do this, it just depends on how you like it. Now you can rewind this video and look again at stuff. It just depends on what you like, what makes sense to you. It is your choice. So let me go ahead and erase this work really quick so I can show you one more way of doing it. There's another way we call FOIL. Okay, and that's just an acronym. It's not a mathematical term. It's just an acronym. So I'm going to use yellow here just because. So I'm going to say FOIL. So that's first, outer, inner, and last. So if I'm going to go ahead and write my equation out again here, x plus 5 times x plus 5. And first I'm going to multiply the first terms. So that's x and x. So that gives me x squared. Then I'm going to do the outer terms, which is x times 5, so plus 5x. Then I'm going to do the inner terms, which is plus 5x. Then I'm going to do the last terms, and that's plus 25. So when I combine them, I end up with the same equation, or expression, I should say at this point, that I had before when I did the box method. So those are just two methods on how to work with quadratics and expand them. And they are helpful and they are foundational. You can do it by yourself any way you want. And then I am one that if you are a guesser and a checker and you just want to go ahead and multiply them in your head, you don't have to use any method. And some of you will get good at that, and that's what you're going to want to do. But those are two methods that you can use for distributing two sets of parentheses. We call them binomials, multiplying two binomials times each other. So that answers that. Now what I would like to do, since we've already solved and we figured out that G of 4 is 81, I want to be able to show you a video that talks about that as well. So here we go. Okay. So we also just plugged in the value for the second equation we've been working with on this screen at G of 4. Again, that's function notation. So I'm saying G of 4. And I'm going to plug 4 in for the x. So let's check our values there. And when we did that, we solved and we got 81. But let's check it on our actual calculator. And I'm going to plug in both the foiled and the unfoiled, which are not really math terms, but they're either x plus 5 squared or the way we multiplied it out to get the quadratic form. So let's plug in this value. So we're going to go open parentheses, x plus 5, and close parentheses, and we're just going to hit this squared term because then that squares our parentheses. Okay, I'm going to show you the graph for that. You'll see it's over here on the -5 is its minimum, and it goes up in both directions. And that we'll talk about the domain and range of that in a little bit when we go back to our screen. But let me go back also and check our, let's put it in the foiled way. So I'm just going to scroll down here. And so we should now, if we've done it correctly, we should have a graph that is red and it goes over the top of the first one, which is blue. And so that one we foiled out was x squared plus 10x plus 25. And this is kind of important, but quadratics are a huge foundational piece for Algebra 2, but also going into pre-calculus. So it's really, really important to understand both. But these are equivalent expressions or equations because we have them attached to y1 and y2. So let's take a look at that graph. And it should be red right over the top of our blue. It is. So you can tell if I was to quiet that second one by just clearing it, if I go down here and clear it, let's see here. Oh, clear right there. I'm sorry. And then I go back to the graph. You'll see I'm back to just the blue. So they're equivalent expressions. But now what I wanted to do is I want to go to the table and I want to test our value. Oh my goodness. We have all of these numbers in here. Well, if you remember, these are the numbers that we entered on the first equation. And since we were asked to see what happens when x is 4 for both of them, you will see this equation right here, which is 81. Or the answer is 81. And that's exactly what we solved for when we were doing g of 4 for that equation. But I can leave these numbers in. It doesn't matter. I can also delete those numbers. So if I come up here, I can just go and delete all of them because I've set it up so that I can ask for specific values. So if I hit 4 again, hit enter, it's going to be 81 because the equation we have in there is that quadratic of x plus 5 squared. So hopefully that helps. And this will end our discussion about the second equation, except for I'm going to talk about domain and range in just a moment. Okay, so this is domain so it's part D. It's actually domain for our second equation because we're working from these now. And so if I'm looking for the domain for this equation, again, it's all x values. So what you don't see here, but this is what happens. This particular quadratic, this is also called a parabola, is going to go on to infinity with the negative x's and the positive x's. So we can say, there's another way to write this. You can write it as, well, I always like to write it as negative infinity to positive infinity in parentheses. That's called interval notation. But you can also say it's all real numbers. So another way to put that is just do an R that has, it looks like it has 2 posts. Let me draw that a little bit better. It's all real numbers. So that's another way. Your teacher will probably specify to you how he or she would like to have your domain written. I have different notations that I use, and I prefer interval notation when I get a chance because it just states it all. So, but that's the domain. Now the range is a little different. The range, the lowest y value we have, let me do that in a different color. The lowest y value we have is right here, and that's at 0 because there's no y values down below here that are part of that parabola. So all we do is we can say our range, y is greater than or equal to 0. And that's it for the range. So that kind of helps you a little bit there. But that ends example 2. And again, you can always leave comments in the comment section on the video, and I'll get back to you if you have questions. All right, let's move on. Okay, so now we're on example 3, and we have 4 problems, I believe it is, that we need to go through. And it's just asking us, how do we answer each of the questions? So each of the questions will be different. This one is, what is the y-intercept of the graph of y equals 2/3 x plus 19? So I'm going to go ahead and write out the equation. Y equals 2/3 x plus 19. So in the world of linear equations, the y-intercept is the constant at the end, meaning the number never changes. And so we call that the y-intercept. You can see a picture of the graph off to the right here, and you'll see that this is 0, 19. So my y-intercept is at 19. All right. That also, there's another part of this equation I think that's really important is to understand is 2/3 is our slope. And I use rise over run as a way to explain that. So if I pick any point, let's just start, let's come down here to this point. I'm going to go up 2 and then over 3. So I'm going to rise 2, run 3, then I have my next point. And that is also an easy way to graph lines. So even from here, I can go up 2, oops, not very straight, over 3, and you'll see another point. But that's what the slope indicates, and that's why the line looks the way it does. So that is part A. So this, to me, part B, does the graph y equals x to the third plus 3x squared minus 4 cross the x-axis? If so, how many times? This is an interesting one, and I find it interesting that the curriculum put this in here first because you will learn something pretty specific later about a point that looks like it's bouncing off the x-axis. And I'll show you that in just a moment. So right now it looks like this only crosses 2 times. But if I go ahead and break this into a series of binomials, so this is -2, and this is 1. So if I use the binomials that would signify those as zeros, I would be saying x plus 2 and x minus 1, but I would be using 2x plus 2 because it's bouncing. Okay, it's not just crossing, it is bouncing. So it's hitting it, and then it's like hitting it down. It's like a double consonant on a word, like the word happy. You know, we don't know why do they have to have 2 P's? Well, it's kind of the same way here. We have to have 2 binomials. It's just bouncing off the x-axis, so we say it's bouncing twice. So let me go ahead and get rid of happy, even though happiness is amazing. We don't need it in the way right now. So if I go ahead and multiply these out, and I'm going to use my outer over inner to do the first 2. So I'm going to say, or not outer over inner, I'm sorry, foiling. I'm going to go first. So x squared plus outer plus 2x plus inner plus 2x times, and then plus the last terms, which is plus 4. That's going to give me x squared plus 4x plus 4. Well, I still have x minus 1 to multiply. So now I'm just going to multiply all of them by the other. So I'm going to do x squared. So that's x to the third. I'm going to do x squared times -1. That's minus x squared. I'm going to do 4x times x. That's plus 4x squared. Then I'm going to do 4x times a -1, which is minus 4x. And then I'm going to do 4 times -1, which is a -4, and 4 times x, which is a positive 4x. Well, these two cancel because 4x and -4x are gone. And then we just combine like terms. So when I combine like terms, I have x to the third minus x, oh, I'm sorry, plus x, 3x, gosh darn, sorry about that, plus 3x squared minus 4, which is our original. So you're going to learn a lot more about this later. But so the answer for this technically in the parent resource guide is that it hits it twice, but it does bounce. So it would be 2 zeros that would represent that. So x plus 2 times x plus 2. And then this one would be represented by x minus 1. So simple answer is 2, but there are a lot of concepts within that answer. So hopefully I didn't bury you a little bit, but those of you parents or students who are trying to investigate a little bit farther, you'll see that there's a lot more to this math than what is shown right now. So let's move on. So here is C. C is my preferred method with this. When I see two equations that are equal to y, I like to set them equal to each other and use systems of equations. So, and that's what I'm going to do on this one is I'm going to use a system. Okay. And so what that means is because these both equal each other, they both equal y, they both equal each other. So I'm going to set 5x plus 20 equal to negative 1/5 x plus 46. And I never like working with fractions. So the first thing that I'm going to do is multiply everything by 5. And the reason I'm doing that is once I multiply 5 by this fraction, or multiply this fraction by 5, it will be gone except for a negative x. So multiply by 5. And let me go back here a little bit. Multiply everything by 5. So 5 on the outside, 5 on the outside. So that becomes 25x plus 100 equals negative x plus 230. Okay, so then I'm just going to do algebra, and so I'm going to add x to both sides. That's going to give me 26x plus 100 equals 230. Then I'm going to subtract 100, and that's going to leave me with 26x equals 130. So when I do that, I divide by 26, x is going to equal 5. So I now know what x is. And once I'm done and I know that, then I can just substitute in to find y. So what I'm going to do right now is I'm going to go ahead and take the, let me go ahead and move this graph a little bit. Okay, move it up here a little bit so it's out of the way. I'm going to go ahead and take the 5 and I'm going to plug it into the 5x plus 20. So now I have y equals 5 times 5 plus 20. And so that's y equals 25 plus 20. So y equals 45, which means my coordinate should be 5 and 45. So what I've done, I've already put a graph here so you can see it. And this is on a scale of 1. So we are at 5 and we are at 45. So another way to solve systems of equations, to verify them, is put them in a calculator and graph them. Where they intersect is considered the solution for the problem. So that ends part C. Let's move on to part D. Okay, so this is part D. This is our last one. And what we have here is a quadratic. And so what it's asking for is the domain. So again, the domain, again, is all x values. So if I'm looking at this graph, I see that all x values will be eventually hit into negative infinity and positive infinity. So I can say that the domain is all real numbers. So you can write it like this. You can also write it as negative infinity to positive infinity in interval notation. So that's the domain. So now range is a little different. Again, we have a quadratic. And so that means we're not going to have all y values because either your parabola is opening upward or it's opening downward. Well, this one is opening up and its minimum is at 10. So this means 10 is the lowest y value we could have. So when I set up my range, I would say y is greater than or equal to 10. Another interesting thing about this graph, this would not be factorable. As you can see, this particular parabola does not touch the x-axis. The x-axis is down here, and this parabola does not intersect. So your answers would be imaginary. You could also say you would have to use the quadratic formula just to even solve to get down to the imaginary numbers, because it's not crossing the x-axis. There are no real solutions. There are no zeros, so to speak. So hopefully that helps. And that ends the Parent Resource Guides examples 1 through 3. By the way, if you like this video, please subscribe. I would like to subscribe and monetize my channel eventually. In addition, if you have any questions, please leave them in the comment section. And I, believe it or not, I will get back to you. And I look forward to seeing you on the next video. Take care and have a good one. If you got this far, that is absolutely awesome. But here is a riddle or a problem. And if you think you have solved it and you think you know it, go ahead and put your answer in the comments. And good luck. See you on the next video.